Hello guys, welcome back to this math course. In today's session, we'll be talking about the cube roots. As we said in a past video, we discussed the square roots and we did talk about some properties. Cube root is not different than any other root, it's just the degree is different. The definition says like if a and b are real numbers and b to the power 3 is equal to a, then b is called the cube root of a. Here a couple different things, or just it's a couple things to remember. It will be a square root did not have a negative number doesn't have a square root. For instance, let me rephrase that again. Negative number doesn't have a real square root. It does have an imaginary number answer, but a square root does not get along with negative numbers if we are dealing with a real number system. But in an imaginary number, we can find the solution for that. But cube root we will find negative number, will find a cube root solutions, so that's not a problem here. So cube root is okay, that will work with negative number. For instance, if -8, cube root will be, so we can simplify, we can write down -8 as -2 to the power 3, and the degree of the root is the index is 3, so this will cancel out. The answer is still -2. All the rules and that we discussed in square roots does apply to the cube roots too, or any other root. For instance, if we have to, for example, if we have a cube root of 3 multiply of cube root of 8, so since we share the same index number, we will pick one index number and multiply the number as a radicand. So 3 times 8 is 24. Cube root is just a preview. That will be almost pretty much the same as we discussed earlier, but from here on we will not use x, this cross sign for the multiplication. We will use dot. For example, will be 3 cube root of 3 multiplied by cube root of 8. So we will use a dot multiplication sign, just because we will be starting algebra, pre-algebra, then algebra, and polynomial in the near future. So we will not get any confusion with x to be confused with a multiplication sign. So this will be exactly the same way. 3, so we can do that. You can write down 3 multiplied by 8 will still give you 3 times is 24, and that should be the same. Okay, moving on to few examples. That example we probably did not talk about, so let's shift the gear. So there's an example given. In this example, it's not asked what to do, but I just made this up. We can simplify, we can move that coefficient into the radicand. So we will just have a whole number, just a whole radical value here. So what can be done? We'll have to find out what degree is the root. In this case, we have a square root, so it's a second degree, or index is 2. So what we can do, we can write down that degree of the radical, which is 2. Write down the radicand already, which is in there, 3. Now multiply that, since this is a multiplication, and raise that to the number of the degree. What degree is that? So raise that to 3 to the degree 2. So this will become, and we study the rule of the exponents. If the bases are the same, we will add the exponents. So the same degree of the radicand, square root, so it will be 3, the same base. We will add the exponents here. So it will be 1 plus 2 will be 3. So if we multiply them, if you simplify, that will be 27. Okay, so that was like that. Hopefully this wasn't that bad example. Moving to the next example. This example is a little bit complicated than the one we just did. We will do the exact same procedure here. So we are trying to get these two alphabet letters inside the radical, or under the radical. So how will we do that? We will have to find what degree is the index, and we will raise each one to that degree and multiply with the radical number already. So let's start it. So what will happen, we already have that a times b squared times c. Now the next term is a squared, but we will have to raise that to the degree of the radical, which will be, we can write them both together, a squared b, and all together with them we will have to raise it to the second degree of the, because that's the degree of the radical. Now we can simplify that. Will be a times b squared times c times a. So we probably did talk about a rule of the power, exponent to the exponent. What we will have to do, we will multiply those two numbers. So 2 plus 2 times 2 will be 4, and that degree is b to the 2. So we will just contribute this power to each alphabet here, each letter. Okay, moving on. We can simplify it furthermore, because we have common terms there. We got a here, and we have a to the power 4. In the multiplication, we take we take same base, and we multiply. We add the exponents. Will be 1 plus 4 will be 5. We got b squared here and b squared here, so it'll be b to the power 4. We got c here. We don't have c on that side, so it'll be c as same c, so not c as same. Okay, so that was not as bad as we thought, because we were just bringing this number inside the radical. So hopefully that was easy and helpful. We will move on to the next example, so stick around, guys. The next example is 8 under the root of 4, and that under root cube. So how we solve this one? Since we have only one radicand here, one radicand number under the 4th root, so we will simplify that, and then we will simplify it to under the square, the cube root. So the procedure here is, we will see like what degree is the first root and what degree is the second root. What will happen is, it will be 3 times 4. We'll have to multiply the roots, and the same will be radicand. That will give me 3 times 4 is 12. Root 12, 8 root 12. So that's how we get the answer right here. Okay, so this example says x to the power 7 under root 4 times x to the power 5 under root 4. So we have the same, it shares the same root degree. What we will do, we will take the same degree, we will multiply that under the same degree. So x to the 7 times x to the 5. And we remember a rule for the exponent. If the bases are the same, we will add the exponents. So x root 4 x 7 plus time x to the 5 will be 5 plus 7 will make it 12. So that is answer for that. Simple. That is only when the degree or the index number is the same. Okay, what if the index number is not the same? we will discuss that in next example. Alright, so this example is a little bit different. We see that there are two different radical numbers. The degree of the radical is different. We have a cube root and we have a square root. So how we multiply these things? So we will have to do a procedure here. We'll have to make it the same root number, and then we can go from there. So to do that, we simply multiply both roots, both index number. So it'll be 3 times 2 will be 6. So 6 is our new root, new index. So what will happen, that is our 6 is our new index number. Now we will divide that 6 by the degree of by the index number of the first radical number. So it'll be 6. So let's write that a squared. 6 divided by 3 will give me the 2 here. Then the multiplication number the same. I'll write down the second radical number here. And 6 divided by degree 2 will give me the power of 3. That will become an exponent of the radical number. And I will explain that. So let's simplify that. Degree 6, our index number 6. So a to the power 2 to the power 2, that will become a to the power 4 time a to the power 4 times to the power 3 will become a to the power 12. And we can that further simplify. So index is 6. So a to the power 4 and a to the power 12 if they multiply together will give a to the power 16. Let's do one more example like that. We have a 3 square root of 3 multiplied by 2 cube root. How do we solve that? As we said, since we don't share anything, I mean the degrees of the radicals are not the same, so we will have to make it the same degree. And how we do that, we multiply both roots, and what we get, so 2 times 3 is 6, and that new number that we will have to divide this number by the index number of the first root, and write it as a power of this radical number. And then the same number, that new root, will be will be divided by the second root index number, and the remainder of that number will become the power of the second radical number. So let's do that. So 2 times 3 is 6. 6 divided by 2 is 3, and that will become power to that. So 3 to the power 3 is that number. The second term is the second sign is the multiplication. So we will just put that multiplication sign back there. So now 2 times 3 is 6, because we had to make it like root to do the operation. So 2 times 3 is 6. 6 divided by 3 is 2, and that the second number was 2, and the remainder of that division was 2. That will become the new power of that second radical number. So let's say 6 is the index number, new index. 3 to the power 3 will be 27, and 2 to the power 2 is 4. If you simplify that, 4 times 7 is what? 28. Correct. 2 is carry bit. 4 times 2 is 8. 8 and 2 will be 10. This is the answer for square root of 3 multiply the cube root of 2. If you multiply them together, this will give this answer. And how we got that, we had to multiply these two roots, itself. So we'll give like root 2, the index number 2, index number 3, multiply them together, we got 6. 6 divide the index of the first root will give us 3, and that will become the power of the first radicon. And then multiply that number as it is, and then 6 divided by 3 is 2, and that will become the power of the second radicon number. So hopefully this wasn't bad. We will do a couple more examples with the division part, and after that we will be shifting gears to polynomial. So hopefully this will wrap up the arithmetic part of the math. We'll be going to the pre-algebra soon, so please stick around. If you have any questions, put it in the comment section. Take care, guys.